judges, we are a team of 3. My name is Jenny.
My name is Robleen.
And I'm Raston. We are here today to talk about our project, which is how electromagnets with different amounts of copper wire turns affect the lifting force of a 50-gram mass.
Before we begin, we would like you to know the contents of this video. We will be discussing the idea and theory behind our experiment, the results, how the experiment was conducted, and why it is important in today's society. We have created a project highlighting electromagnetism. In order to do this, we have assembled 2 electromagnets. The first one has 258 copper wire turns, whilst the second one has 360 copper wire turns. One was provided by our school, and that one has 600 copper wire turns.
First of all, why did we choose this idea and what's the theory behind it? We wanted to see and show how electricity and magnetism can work together to generate a magnetic field. Maxwell's theory of electromagnetism has related electromagnetic waves to charges. He explained that an oscillating charge will produce a changing electric field, which in turn produces a changing magnetic field.
We ordered the necessary equipment and set up the equipment in our science classroom. We placed each electromagnet on a retort stand the same distance away from the 50-gram mass and observed how much of the mass it could pull as we increased the volts. We observed the pulling forces for 2, 4, 6, 8 and 12 volts, repeating each trial 3 times to ensure accuracy.
To control the distance, we placed 2 50-gram masses and placed the electromagnet on top. Then we took one mass so that the distance between the electromagnet and one mass is the thickness of one 50-gram mass.
What did we find out?
The school's electromagnet with 600 copper wire turns indeed had the strongest pulling force, but our student-made electromagnet with 258 copper wire turns had a stronger pulling force than the second student-made electromagnet. How so?
That's because adding more turns to an electromagnet can increase its electrical resistance and reduce the current flowing through it.
Our project is also important in today's society. You might be wondering how. They can produce a very strong magnetic field, and its strength can be controlled by varying the number of turns in its coil or by changing the current flowing through this coil.
Electromagnets are also of vital importance when it comes to making electric motors and generators. Understanding the number of turns that affects the strength of an electromagnet can help improve the design and efficiency of these devices.
Thank you!